Okay, welcome to Unit 2, Day 1. We will be talking about slope in this lesson video. We're going to start with a review of what slope means and how it applies to some real-life situations and how to calculate slope and things like that. So let's get started. You should have your own piece of notebook paper, and you should title this lesson Unit 2, Day 1, Slope. And whatever I write down, you need to make sure you write down as well. And since this is the first video you guys have had to watch for class, I'm going to be kind of giving you some instructions along the way, so it might take a little more time than usual. But make sure if at any point you need to pause the video to copy things down, go ahead and do that. I will be collecting notes at the end of the unit to make sure you have these written down and copied correctly, and you will get a grade for them, so make sure that you are doing this. All right, first of all, let's talk about what slope means. Okay, the word slope refers to the steepness of a line. All right, the steepness of a line. And there's a lot of possible slopes we could have then. Okay, in general, slopes could be positive, meaning going up and to the right. Okay, or they could be negative, going down and to the right. And then these two special cases, if we have a horizontal line, excuse the bell, if we have a horizontal line going just left to right, we say that has a slope of 0. But if you have a vertical line going straight up and down, we would say that that is an undefined slope. Or we would say no slope. Okay? All right, so there are some ways that we can talk about slope. All right, so I want to copy those down. Okay, in general, while slope does mean the steepness of a line, if I gave you a real-life situation with words and like a word problem, slope would be a rate of change between two quantities. Meaning two measurable values, your x's and y's. Okay, but slope could also be used with numbers on a graph. If I gave you the graph of a line, we would say that slope is rise over run. Okay, it's a rate. Okay, that means it's a fraction. The amount of rise over the amount of run. This would be your up and down measurement. Run would be your left and right. But if I didn't give you a graph and I didn't give you a word problem and I just gave you ordered pairs, we could talk about slope using a formula. Okay, that would be this formula, m equals, we use m to represent slope. The second y coordinate, so y2, minus the first y coordinate would be your rise. y2 minus y1 would be your rise, over your difference of your x values. Second x value minus first x value. We call that x2 minus x1. So depending on the different given information, you will need to use these different ways to calculate or find slope. So let's talk about if I was using the rate of change. Okay? And this is if I were given a table of values. If the starting information is a table of values, we're going to think of this as the rate of change. All right? We're going to think of this as the change in the y values for my rise over the change in the x values. Okay? And so you're going to be given a table sometimes, and we're going to need to calculate how we find slope using that table. So let's look at our first example. A lot of times you're given a table of values like this, where they list the x's on the left, the y's on the right. So let's say I gave you these values. 0 for x, 1 for x, 2 for x, 3 for x. And then the other values that match up on the y side would be -5, -3, -1, and 1. To calculate the rate of change or slope of whatever this line is represented, I don't have to actually graph it. In order to calculate the rate of change, we're going to look at the changes in all the x values and the changes in all the y values and see and make sure that they are consistent. So the x values are always changing in this column by going up by 1. That's a plus 1 for each change in the x values. And the corresponding change in the y values every time, if you look at how to count that, -5 up to -3 is a plus 2, -3 up to -1 is another plus 2, and so on and so forth. And I could continue this pattern on, okay, even another line. By adding 1, I would get a 4 here. By adding 2, I would get a 3 here. So if I needed to continue that, I could. And so what we need to look at for our slope, our rate of change, our y values always go on top, so that plus 2 amount goes on top, and then our corresponding change in the x's is a plus 1. So that fraction, 2 over 1, simplifies to 2. Okay? So we would say that our rate of change, y's to x's, would be 2 over 1, or a rate of change of 2. So let's take a look at another example. Sometimes I give you the table vertically like this, but other times I give you the table horizontally like this. Okay? So here, my x values would change. I'm going to just show you what those x values are. We would start at 3, then go to 6, 9, 12, then 15. Now, I'm just coming up with these and giving you these examples. You don't have to worry about where I got these numbers. I'm just making them up and showing you these examples that I've chosen ahead of time. And then the y values that correspond would be 5. That means when x is 3, y is 5. That would be a point, an ordered pair. When x is 6, y is 4. And then y goes to 3, then to 2, and then to 1. What I would like for you to do is to help me find that slope, or rate of change, meaning find the change in y over the change in x. And I want you to pause the video here and try this one on your own, doing the same thing we just did in this example. When you're ready to continue, just push play and check your answer. All right, if you need more time, again, please pause the video. Otherwise, this is what we should get. Okay, every time our y changes from going from left to right, we are subtracting 1. But every time we go to the right for our x values, we're going to go up 3. So that's adding 3, so on and so forth. So our change in y's is -1. Our change in x's is +3. -1 over +3 is just the fraction -1/3. So the rate of change here is -1/3. I ran out of room, so I have to change to a new page, or to the back of this page. Now we're going to look at another way to calculate slope, or another way to talk about slope, and that is when I'm using a slope formula. Okay, and we're going to use the slope formula if I am given 2 points, or 2 ordered pairs. Okay, so I'm not given a graph, I'm not given a table. If I'm just given 2 ordered pairs, I'm going to use the slope formula, and I'll remind you of what that is from earlier in the notes. y2 minus y1 over x2 minus x1. So here's our example using our slope formula. Okay? Let's say I started with these 2 ordered pairs. 2, -3, that'd be a point on the graph. And then the line goes through a second point at 4, 15. And so what we're going to do is identify these numbers as y2, y1, x2, and x1. Okay, y2, hang on, that's a little blurry. Let me fix that. There we go. Sorry about that. y2 would be the second y coordinate. That would be this one. Remember, ordered pairs are always x first, then y. y1 would be the first y coordinate. Okay, similarly, x2 would be the second x coordinate, meaning the x coordinate from the second ordered pair. So that's x2, and that means x1 is 2. So we're going to plug these numbers into their appropriate places in the formula. Okay, y2 is 15 minus y1, which is -3. When I have a double negative like that, that'll need to be changed. But I'll do that in a minute. Over x2 minus x1, 4 minus 2. Like I said, double negatives minus a negative changes to plus positive. 15 plus 3 would be 18. And then 4 minus 2 is 2. And this fraction can be reduced. It can be simplified. We can do 18 divided by 2 and get 9. So the rate of change, or the slope, of a line going through these points would be 9. Okay, and that leads me to the third way that we can talk about slope, and that is in the phrase rise over run. And we will use rise over run by counting rise and counting run when we are given a graph. Okay, so I know we don't have graph paper here, but I'm going to use the margin of my space here to kind of create a line graph, or a coordinate plane. Okay, and somewhere through the middle of that, I'm going to make my other coordinates go like this. And I'm going to mark it out. Okay, that'd be 0, 0. There's 1, 2, 3, and 4 on my y-axis. And -1, -2, -3 on my y-axis. And I'm going to space out some points equally spaced out for my x-axis. 1, 2, 3, 4, and 5. And on the other side, I would have -1, and I left room for -2. That's as far as I have to go. So on that graph, don't forget to label your x-axis. Let's say I gave you these 2 points to start with. This is our fourth example. Let's say I gave you a point at 0, -2 on the y-axis there, and I gave you another point out here at 3, 0. And I graphed that line through those 2 points. Okay, a lot of times I'm going to try and print these graphs for you. You won't have to do this on your own yet. But to calculate slope, that's just going to measure the rise over the run. So that means I have to pick a point to start with. I'm going to choose the point on the left. I almost always choose the point on the left first because we read left to right, so I move left to right. Okay? And so I'm going to calculate the rise going from here to there. Well, that is a rise of 2 vertically. Okay, so that would be up 2. Anytime I'm counting up on a graph, that is a positive 2. And then I'm going to look at the run, which is left to right. So to move from here over to here, I'm going to count 1, 2, 3. That's to the right 3. Anytime I move to the right, that's a positive amount for the run. So it's positive over positive, so my slope is a positive 2/3. Now, I would like for you guys to understand that if I count down, that would be a negative rise, or if I count to the left, that's a negative run. Okay, so let's make our little note to ourselves. Up is a positive rise. Down is a negative rise. To the right is a positive run. And to the left is a negative run. Okay, we're going to do some more video or some more examples and practice on this in class. So make sure you have these notes to look back at.